1. Okay? So, without further ado on this, let's get going on it. What I am doing is I am isolating one part on the periodic table. So the third period, right? We're just talking about the third period here. So when I'm looking at the periodic table, it's sodium all the way to argon. All right, so when I look at that, if this is a surprise, I'll actually say this and lead into this. Some of us, it's getting a little frustrating. I'm not understanding electron configurations. I'm not understanding this or that. You have a chance to reboot today. There are things here that you can easily recover from still because of what we're going to take from it that's most important. What is happening?
I'm sorry.
This is already going to be hard enough. So when I look at Na, for example, that ends at what? That ends in the S group. So it's going to be 3s1 because it's on the third row, right? So I know that I would have ended on 3s1. Right? The last spot is on 3s1. And then as I go, I hope that this is not a surprise that this would have been at 3s2. So what happens here at Al? Because we're going to fill this in then at your own pace in a second. Where does the next electron start filling in at? In the P's, right? The 3 P's. So it would look like this, for example. So I'm going to start filling these in. Please note, it goes all the way across, right? Before we fill back in. So fill these in because this is a good visual for you for everything else on this sheet. And then when you're done, I do want you to fill it all in. And you're like, oh, but gosh, it's so much work. But it's going to have a lot of meaning for us later. You can do it so quickly. It's not my first time. The way that we have the note sheet, we're really eliminating a lot of the work that you're going to have to do and a lot of the notes that you're going to have to write, though. So that's going to be a positive in the long run. So the whole point is for us to visually see where those electrons are. And what we're noticing is that we're gaining them on the outer level. Now, if you're looking at this and this just looks completely foreign and you have no idea right now, it's still okay. You still got a shot. So I'm looking at the outer electron configuration, and the outer one on this one is 3s1. I'm writing it big just so you can see it. I wouldn't cover up everything. This would be 3s2, and then here's the key, because you can fill this in yourself. A lot of people are going to make a mistake and simply write 3p1. When we say outer energy level, we mean all of the ones with the numbers. So it's all of that. So this is 3s2, 3p1, 3s2, and then you can fill this all in. 3p2, 3p3, we continue on, but you don't lose that s. So you should end at 3s2, 3p6. And I'm just adding one each time. So even if you struggled at getting all of those other ones, I should be able to look at a periodic table. I should be able to say that it's in the p block on the fourth column. And, oh, that's an s. Oh, that's p4. Yeah. What I can't lose sight of is those s's, though. And why? Because that leads into our next line. Valence electrons are number of electrons in the outer energy level, not sub-level energy level. So this is S1, so that's a 1. This is S2P5, so this is a 7. So you can probably see what I'm going to fill in. It's 1, 2, 3, 4, all the way to 8. That should work. I guess not. All right. Okay, so that's we've learned all that. Today what we're going to do is take these numbers and we're going to turn them into dots. They're called Lewis dot structures. And it's pretty straightforward. I want to just point out something. Is if you have a letter, like a C or a CL whatever it is, there's basically, you don't have to draw any of this yet, there's 4 sides. Right? There's 4 different sides. So we're going to, when we put our dots on there, we're going to place them on one of the 4 sides. It's not like we're going to randomly put them at an angle or something like that. So when I look at sodium, I have 1 valence electron. So I'm going to put a dot on the outside of sodium. That signifies my 1 valence electron. We are also going to try to spread these out as much as possible, even though that's not a Octet rule. So magnesium, there's 2. Notice though, I'm not pairing them up. I'm not like doing this, like there's 3. I'm going to spread them out. There is no rhyme or reason though. If you're like, oh, he put it on the top, that means something. It means that I put it on the top. I could have put it on the bottom. I could have put it on the side. So silicone would have 4. And now I have to start pairing them up because there's 4 sides. So the maximum we can have are 2 on one side. So there's 5. There's 6. There's 7, and then 8. The only rule that we really have is that you got to have 2 electrons maximum on the side, and we try to spread out all the single electrons as much as possible. If you do that, life's going to be really easy for you today. And for the rest of, this is going to be used a lot. It's going to help us bond electron, or an atom to another atom. All right, next line. We actually know how to do this, but this we do struggle with a little bit. So it says atom must gain or lose blank electrons to achieve stability. If you have no idea what that means, basically this is what we need to do. We need to have 8 in its outer energy level. So you have 2 choices. You can either add to get to 8, or you can wash away what you have. And why do I do that? Don't do this to yours. But if I wash this one away, or I wash any of them away, whatever it is, I have dropped down to that next level, and now I have 2, 4, 6, 8. Hey, there's 8. By getting rid of, I could also get 8. So here's your choices. You get rid of them, or you add. So I could add 7, or I could lose 1. You always pick the smallest number. So in this case, I would lose 1 electron. I come over here, this has 8, so let's just, we're not doing, like just cross, we're not doing anything with that. This one has 7. I could lose all 7, or I could simply gain 1. 1's a smaller number. So I'm going to gain that 1. Please stay with me. Today is a very important day. And then we can keep going. I could gain 6 or lose 2. I'm going to pick the smaller number. I could gain 5 or lose 3. And where are you getting the lose from? I'm getting rid of all of them, or I'm adding to get to 8. I'm getting rid of those 3, or I'm adding 5. 3 is a smaller number. This one, what could I do? I could gain 4, or I could lose 4. Well, I guess both. So I'm going to circle both. It's going to be a little confusing. We'll get there. I could gain 3 or lose 5. I'm going to gain 3. And then gain 2 or lose 6. I'm going to gain 2. So Mr. Blackford last Wednesday, talked about how the lefties are losers. Not about you guys, but more to the left, they lose. They're losing electrons. That's the whole point, and know what that was about. So the last part we haven't really done, but I think you can make that leap. We are losing electrons. And what are electrons? They're negative. So if you lose 1 negative, you become positive 1. If you gain 2 negatives, you become negative 2. So what I'd like you to do right now, especially if you have pencil, you can do these. If you lose, you become positive. How positive? However many you lose. If you gain, you become negative by however many you gain. So why don't we put those in right now and see if it matches up with what I have written there. And then you can see if it matches up with what I have. Yeah.
Could our dot just be like 0 for the?
Yeah, you could write 0. I just put a dash. Like I didn't even want. Like I didn't mean a negative. It's like it's nothing. Like I didn't even want to talk about it. So hopefully that matches up. So I'm +1, +2, +3, -1, -2, -3. All right, so all this, do I need my sheet every time I do this? No. We talked about in class that I can figure out, these are, by the way, right here, this little box, these two, vital. Can you say that this says 1, this says 2, this says 7 or 8? By the periodic table, what's the clue? It's the number in the column. So these always have 7. Every one of these has 7 valence electrons. There's a 7 in that number. These all have 3. These all have 5. So it's whatever number's in. Now, don't worry about the middle. But these 2 and these 6, they work out with whatever's in the top of the periodic table. I don't know if I have that right in here. Well, it's hard to read. Okay, so that is kind of the rules of things that we've learned about with bonding. If you want to flip the sheet over, please. Let's talk specifically about some things with bonding. All right, now, we're not doing all this at once, but we have to learn the difference, and then we're going to focus on just one for this chapter. So there's covalent bonds and there's ionic bonds. And if you could, kind of underline the word co, because that can kind of help you. If you're a co-owner or a co-worker, you are kind of doing something together. You're sharing. So that's what this is. This is sharing. You are sharing electrons between atoms. And there's a picture of that. So they have access to the electrons, and so do the other ones. Right? Some of you are really good at sharing. Every time that you take out a piece of gum, you turn to someone and go, hey, you like the piece of gum? Some of you are the jerk who you see somebody across the room that has a piece of gum, and you always ask for the piece of gum. They didn't offer it at all. Hey, can I get a piece of gum? Every time. Hey, can I get a piece of gum? I've never bought a piece of gum in my life. Every time someone gets a piece of gum out, I ask for a piece of gum. It's amazing. Not so friendly. That other person was, though, so they're really good at sharing. But maybe you do. Maybe you bring it once in a while. Like, do you open up, what are those? It's a tin. Oh my God, my kids love these. And there's like a little one. It's like for you, and then to share. Like, do you have the one when you open it, it's got to rip the sticker? Are you the person with the tin that's never had the sticker ripped on the share one, only the individual, or do you have them both? It's a good test to see where you're at. All right, ionic, a little different. It's basically an attraction. It's an attraction. It's like, think of magnets. They're charges. Opposites attract. I don't believe that except in science, personally, but attraction between large numbers of cations and anions. So one of these are positive, one of these are negative. And you do have to know the difference. Okay, so this is a way, this has been passed down to me by a monk in the Tibetan mountain range here. But in this open area right here, I'll draw it. It's not just the cat. It's a plussy cat. Now, those of you that are not good at drawing or don't understand drawing, that's a plussy cat. That's a dead cat. Okay, X's versus pluses, very, very important in your drawing. Right? Every time you put an X, it's dead. Every time you put a plus, in this case, it's positive. So cations are positive. Cat plus positive. Oh, genius. Not dead cat, though. It's a plussy cat. Now, you're like, but how? Gee willikers, how will I ever learn the anions? Please give me something to learn from it. First off, I'm not going to actually formally give you something because if you know them both, you just remember plussy cat is the positive. Cat, positive. But I'm going to draw something. I don't encourage you to draw this. So I saw this in a science book. So this was in a science book and said, students can use this to help them remember anions. So I'll just draw this. I would not draw this, though. Don't draw this. So this was actually drawn in a chemistry book, and it said, this will help them understand it's an anion because, so what is this? It's an ant. Okay, so I already have issues with it. It's not an antion, it's an anion. Secondly, they continue to write. These are people who apparently have degrees in science. I'm not a big biologist, but I do know a little bit about ants. A little bit. You know, I've run into them a couple times in my life. And they said they'll remember anion because the body of an ant is long and thin, like a negative sign. But ants have segmented bodies, right? They have like parts. So like that's just like horribly wrong. So I just thought, well, that was stupid. And then this name was born. He became, this is a bubble pipe. Don't worry, no tobacco. So he runs on cane. So he just goes, it's stupid ant. This is stupid ant. I know, it's really original. I mean, it's like, how did you come up with that name? I'm like, I don't know. It just sometimes it's organic. It just comes. So he's got a bubble pipe. He's angry. He walks on canes. So if you ever hear the ticking in the middle of the night, maybe stupid ant is coming to get you. All right. Electronegativity. Let's rewrite this in a better way. Okay, stay with me, guys. So we learned a bunch of trends, and I know that they probably just kind of fell on your face and fell on your desk, and then you pushed them into the garbage or onto the floor, and like, I'll just remember a corner and I'm good. Totally agree. But as we go, we kind of told you this from the beginning, is that we're going to kind of isolate one at a time, and this is a really important concept. So basically what it is, electronegativity is when you have two bonded atoms, one of the atoms is going to pull the electrons away from the other one. That's what electronegativity is. So if you have a great or high electronegativity, you can pull those electrons more than someone else. So I have three atoms here, and what I want to do right now is let's fluff our bunnies here. If you don't know what that means, make electron clouds. Make two that are exactly the same size. And just label this once. This is an electron cloud. The size of an atom, how atoms interact, how atoms bond, it's all about whether or not they have electrons and how many they have and the interactions between the other ones. So, if you notice this, so you could go over to your friend's house. And let's just say you bring some toys. So you have some My Little Pony, G.I. Joes, and they have G.I. Joes. Avery was excited until I said G.I. Joe. You know, and you both bring it, and you know what, maybe you don't have everything. Maybe you have Twilight Sparkle and Pink Cobra Commander and Destro, you know, and maybe they have G.I. Jane. I forgot the names. Who's a good guy? Who's a Joe? Snake Eye. Oh, he was cool, but you could never know if he was a traitor. So you could share, and you could share equally. Maybe you're playing video games and you both are really nice about it. Hey, it's your turn. No, now it's your turn. Now it's your, and you all get equal amounts and you can all play. But yet, it's not like at the end of the day when I go home that they get to keep my Applejack and my, Cobra vehicles. I get to take them home with me. Okay? So that, there's a benefit, right? There's a benefit of sharing because you get access to their stuff and they get access to your stuff, okay? But then you have that other friend. You know that friend. Are you this friend? I don't know. You have that friend who makes those rules up, like they're playing on your Xbox, and like, oh, no. When you lose 3 times in a row, win once, and then lose again, you get to go again. Everyone knows that. You know, and then they get to go again, and they're not sharing. You're like, but it's my game. And they don't share very well. So I'm striking a nerve here, and everyone's getting excited.
Yeah, now you gotta suck in Barbies. Yeah, you guys bringing up bad memories.
Or someone could come and play with all your stuff, and then they didn't bring hardly anything. And then it's like, then you can't even compare the cutie marks.
Or when they take the Barbie doll dress.
And never bring it back?
Yeah, and she still has it to this day.
I know. God.
Actually, I sold
And how is she supposed to go to the prom in her Malibu Barbie beach set and when she doesn't have her sparkly prom dress? Because you said prom. Okay, here we go. So, if this atom has a little more negative on it, and this one has a little more positive, make a little negative sign, make a little positive sign. So that side's going to have a little more negative electrons. This side's going to be a little more positive electrons. And then, you know what? I got ahead of myself. Let's talk about that gum guy again, or gal. Because, you know, gum stealing can be anybody. And this person has the gum. This person's like, oh, what? Gum? What? Gum? And you take all the gum. I'm striking up bad memories. Everybody, no one's going to talk to each other when we leave today.
Hayden always asks for gum.
So if they completely take them, make a big negative.
I don't ask for gum.
Okay. Sorry for trying to make it interesting. Just bring it. Okay, give you 30 more seconds to get rid of your past demons here. Clearly, we need to do it.
Yeah, I know, you sold it. I think we got mine.
15 minutes and I was chewing on a piece of rubber.
All right, that wasn't 30 seconds, but in my mind it was. Okay, here we go. We're bringing it back. All must feel better or worse. Who cares?
Definitely worse. Yeah.
Okay, so covalent, guys, is about sharing at some level. It doesn't matter, though, if it's equally or not, if there was some sharing involved. Don't make this really big, but just write covalent here. Don't make this really large because you're running out of room, I'm sure.
Oh yeah, definitely already out of
No. You'll make it work. So, what we call this then is that because these are totally equal, and there's some numbers on the side, we'll talk about these in a couple minutes here. What's on the top and the bottom of our Earth? What are those things? Those are poles. Right? I guess there could have been a lot of answers to that. Oh my God! Okay, guys, can't keep doing this. We have very minimal days. We have a quiz no matter what on Monday because we aren't coming back for basically a week then. So this is like vital. So because there's no difference, what we in chemistry call poles are charges. So there's no charges here. Here there are some charges. So we call this polar. This is non-polar. This is polar. You're like, but the other one has even more charges, right? But they're not sharing at all. So this is that other kind of bond, and that's ionic. So how you're going to learn, or how you're going to know when something's non-polar, polar, ionic, and sometimes you will see it said as non-polar covalent or polar covalent or ionic, is that there are numbers on the side. So it's not about memorizing, but if you just look at them for a second, the higher the number, the bigger the bully. The higher the number, the more that atom can steal electrons from someone else. But if I have two different atoms and I add them up, or I take the difference, so I subtract them, and I get a 0 to 0.4 range. Actually, let's do this. Then it would be considered non-polar. Oh, jeez. So I will show you this at the end of the day in your notes, but in your homework. But just do this right now. If there's a little bit of a difference, then we're going to call it polar. And then if there's a lot of difference, meaning that one atom is stealing a lot, and my numbers are 1.8 or more different, that means that one of them is a crazy bully, and they're stealing your electrons. Yep. Okay, stay with me. Stop going to Gumland and prom dresses and all this stuff. So, it all comes down to this. Octet Rule. Last big thing we're writing, and then we're just going to write a couple checklist ideas, and we're going to do a bunch of examples. It's all about the Octet Rule, and this is a longer definition, but then I am done with this sheet. Figure it out. Make it work. So we are trying any means possible. And I have one last thing in parentheses right below this, and I know you're like, but I'm already all over space. By any means possible, scratch, crawl, kick, punch. We are trying to gain, we're losing, we're sharing, we're trying to get to 8. Okay, one way or the other, Octet Rule. So right there, if you didn't know even that octet meant 8, then you had a hard time playing with the books that had things about like an octopus. And I'm sorry, bringing back other bad memories. There is one rule though that cannot get to 8. It's the Duet Rule. What 2 atoms physically cannot have 8 in its outer energy level? Which 2 cannot get there? Avery?
Hydrogen.
And? Good. And you said you didn't like this class. Look at you, Starsty. That's it. Hydrogen and helium. Why? Because at 1s, you can't have a 1p. So that's the only one. All right. So here's your decision. I personally would do this in my notebook on a fresh sheet of paper. Some people were doing it on the back of either their schedule or their little half sheet. I would not do it on the half sheet. You're going to run out of space. We are going to do 3 examples and do some checklists about practicing how to now put atoms together. I would do it in a notebook. But if you want to do it on the back of that, you can. You have enough space for it, for sure. But I would not do it on the back of the half sheet, the little one. You will need the half sheet, but don't write on the back. So, I'll give you a second. Just hold on. If you're wanting to do something, you can write Lewis structures on the top, or Lewis dot structures if you want. You don't need to write the word checklist yet. Can't really cross out something green with green, I just found out, huh?
You can.
Lewis dot structures, that's what my title would be. Lewis dot structures. Let's go. Lewis dot structures. Ladies, let's go. I know. Lewis dot structures. I meant to have the dot in there better. A lot of times you'll just hear them as Lewis structures, but I want you to hear the word dot for this one because we're going to be making dots. All right? So, don't be just copying brainlessly then. Brainlessly. There's a word. Okay. We're going to front load this. So way to the left. I do want you to make a checklist. If you want to write the word checklist, that's fine, or just make a checklist. So instead of these right here, what you're going to do is just squares. You're going to do 2 things. Don't do anything else yet. You know what? I'm going to stop you from writing other stuff. So checkbox, write valence electrons. Don't actually put a check in it, so just making a box. So those aren't there right now. And write valence electrons, and then another checkbox and say octets, and then you can write what I have written on the bottom, which is saying the exceptions. Guys, you have 118 elements on the periodic table. The fact that I wrote exceptions and I wrote 3 letters, that's a pretty good deal. I'd take it. Because there are a lot more exceptions probably than this. And we are not going to touch those. Okay? Then, the final thing I want, it's not a checklist, but I would write tip. And we are not doing that second one. I'd write find center atom. And then I'm going to have you write one more tip in a minute. So just write like tips maybe on the side. Like if I were doing my notes, I'd write tips. And then I would write that first one. Find center atom. Okay? So I'm front loading this. We haven't done anything yet. It's going to be amazing what you can do in a matter of about 15 minutes here. Maybe you've done some of this stuff before, maybe you haven't. Okay, so my suggestion, I would not write anything right now. If you want to do this later, you can, or put it on the side, because I want the rest of your sheet, at least on the right side, to be the actual examples. But if I have these elements right now, I want you to just observe this, because these are kind of, without us writing, I mean, we could write rule after rule after rule, and that's what this half sheet is a little bit about, is there's a lot of rules and tips. I don't want to write them all down again. You have some of them. But if I did this, how many dots does B have? 3. Why? Because it's underneath the number 3, right? So won't the next one be 4? And then 5, 6, 7. Okay, so I'm just going to do these. Please, just observe for right now. I'm going to make this bigger. So I have 3. Oh, how big those are. 4, 5. Let's go there. 6, 7. Okay. What you need to know this has no meaning to you yet, and a lot of you are writing, and you don't need to right now. This is just for you to observe. Is that the goal when we're bonding is that I have an electron, you have an electron. If those two electrons get close enough, you can share, and you can have my electron, and I can have your electron at the same time. Like this picture right here. This brought that electron, and that one brought this electron, let's say, but they're sharing them together. So the goal of us today is saying if there's a lone electron, and this is just a visual, is that is going to reach out and try to find another bond. That's how a bond's going to happen. So in theory, boron can bond 3 times. Carbon can bond 4 times. But how many times can nitrogen bond?
3.
Why 3? Because there are only 3 lone electrons. We're learning. How many times can oxygen bond? 2. And 1, right? Okay, let's take this to the streets. No, let's go up here. So your first example. I would write example. This is my own way of doing notes, but however you want. And then let's write PF3. Don't go further than that, though. So I would do this now in the big open area, to the right. Like, we're doing big stuff now. This is to the right on my sheet. Like, this is big stuff. Not underneath your checklist. Don't write on your checklist right now. Okay, so let's do this first. I need to know how many electrons, how many dots I should be playing with. So if I look, stay engaged today for the next 20 minutes, and you're going to be really strong in this. How many electrons does P have? 5. How many does, what is it, F? How many does F have? 7. So what I'm going to write, I have 5, just write that there. I have 7, and then I have 3 of them, right? So I'm going to go times 3, and you might just want to do an arrow just to say, oh yeah, that's where I got that from. So I have a total of 26 valence electrons, right? Okay, I'll show you how this works. So, first rule, tip, find the center atom. This is what your center atom is. It's outnumbered and or bonds, this is so eloquent. It can bond the most. If you can find the center atom, you are going to get a better chance of figuring this out. I'm going to come right back to this, but this is what people do. Oh, right here. They take PF3 and they go PFFF, and you just want to make one big long line. It's not a center atom. Nature finds the center atom and all bonds to the middle. So if I can find the thing that's outnumbered, and if that's not an easy answer, then which one can bond most? Well, what do you mean by that? Which one has the most circles on it? That's what I would be. But this one's pretty clear because, I'm going to move this over here for now, is that the P is outnumbered by the F. So my center atom is my P. So I'm going to write that right in the middle. And instead of writing a ton of notes, I'm just going to, it's important for you if you need to write extra things, I'm going to just verbally say some of this stuff. Then I want to surround it evenly, symmetrically. So I wouldn't do this, like, well, hello. Like they meet in a bar, like, oh my gosh, I'm outnumbered 3-1. They're going, all right, let's go. And then they're like, ping, ting, ting. Okay, bad sound. I got to get rid of this stuff. I want to get rid of that. There we go. So I'm going to surround it evenly. So then what I have here now is I'm going to put the electrons on there. Here is my goal. What did I do? What did I circle? The ones that were paired or the ones that were by themselves? By themselves. So here's a goal. If I have the center atom like this, notice what's already happening. Those single ones are the ones that are going to be like bonding. It's like Spider-Man. I'm going to hit it there. I'm going to hit it there. So if I have fluorine, you tell me which one looks better. If I do it like this, which one makes sense with what I'm trying to do here? The left or the right? The left, because I want to bond. I want it to bond. So I want the single one. So you got to plan a little. And I know you just learned this, but I already feel like we can start talking about this. Because I want to try to plan for those electrons to pair up. So the last one should make sense that I want to do it this way. Now, as we do this, you guys are going to get faster at this immediately. You're going to be like, oh, well, then this would just do this. So then what I have, I'm just going slow on the first one. I see a lone pair, I see a lone pair. That's going to be a bond. That's going to be a bond. That's going to be a bond. If you saw it early, some of you would go, oh, shit. Some of you go, oh, well, that's going to be a bond, and you're just going to draw a line. Now, you don't want it so it's a big dumbbell, though. Like, hey, I got these two dots, and then I got this little line, and now, like that's not what's happening. But if that's the case, that's fine. Here's what I'm trying to tell you, because you're going to have to do this eventually if you're circling. A lot of you, I need to urge you to stop circling by the ending of this hour already as much as you can. This is great right now. We need to clean it up. This is not a final answer. So right here, if I talk about this, what it means, it looks like that. Like those are both sharing, or some people will view it like that, but they're between them. So that P has access to those two, and this F has access to both of those. So here's the final answer. You need to rewrite it once. And what I would draw then is, it would look like that. And we have one label to do today. It's called a single bond. When I make a bond line, then, what does that always signify? How many electrons are in a line?
2.
2, every time. So, here is what happens. So a lot of times, again, you're going to start seeing where the bonds go. If you're like, wait, I'm going to have a single electron here, I'm going to have a single electron here, I'm just going to make a line right away. Awesome. That's what we want you to do. How do I know I did it right? What's awesome about doing these is that by the time you're done with the problem, you will know if you got it right or not by doing these 2 checks. So if you're writing, you need to just look up, because it doesn't have meaning without seeing it. The valence electrons, I need to say I had this many dots drawn in here, electrons. So don't mess this up like by counting something twice. I have 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26. It will always be, for you, an even number. So if you ever got an odd number, you did something wrong. It's called a free radical. That's not happening right now. So you have 26. This has 26. Check number 1. Still not necessarily right. Second one, everything has to have an octet. This is the confusing part. Everything touching the element counts. So if I cover that up, this is where you have to see it. 2, 4, 6, 8. Okay? 2, 4, 6, 8. 2, 4, 6, 8. But then you go, well, you've already counted those. But this is sharing. I don't want to bring up your friends right now and whatever you've done or haven't done to each other. But if you're sharing, in theory, you both have access to it. So this P right now has 2, 4. I'll change the color. This phosphorus still has access to all of these. So that's 2, 4, 6, 8. So I just did 2, 4, 6, 8, 2, 4, 6, 8, 2, 4, 6, 8, 2, 4, 6, 8. So everything has an octet. So I said, yes, I have the right number of electrons. Yes, I have everything has an octet. It has to be right. So I know I did the problem right. Because sometimes we're like, oh shoot, like last hour I accidentally didn't bring the dots over. And then I started counting. Not only did I not have 24, but I didn't have an octet. Like, oh shoot, oh yeah. I need those 2 up there. Okay? Compare and contrast. We got to do more. So let's do another one. So right below that, whoopsie. Right below that one, let's do another example. HCCl3, by the way. Great question last hour. They thought that was another carbon and 3 iodines. Always ask. If you're not sure if it's a chlorine or not, ask. Okay, that's a chlorine. So what I'd like you to do right now, I'll do the first one. That has 1. Can you add up all the electrons? So just look at the periodic table, right? The numbers are above. I want them all added up. Let's do that. So, by the way, why I didn't want you to write this down, it says become familiar with the general number of bonds for each atom. What I mean by that is that's what I was circling. Like, carbon's always going to bond 4 times. And a halogen or an F is always going to bond 1. And oxygen had those 2. Like, the more familiar you get with how many they bond, the easier this gets. But there's one last thing I do want to write down to the side of our checklist. And I'm going to do that in a second. So let's see if you got this right. So hydrogen was 1, carbon was 4, chlorine is 7 times 3. 26. Total coincidence. Doesn't mean that, oh, I never have to count these. It's always 26. It's not the case. Okay. What is my center atom? Well, let's just talk about this for one quick second. No, don't write any of this. What's one of the rules with what I said about the center atom? It's outnumbered. Okay, well, not everything's outnumbered. Secondly, it's the one that can bond the most. So how many times can hydrogen bond? Just once. And nitrogen or chlorine can only bond once. So that would be a really bad center atom if it's like, I got you. And it's like, I will get you all in this one bond. Doesn't make sense, because I can only bond in one atom. But the carbon can bond 4 times. So my last little tip is that H's and halogens I can spell right. This is not an absolute. It's not an absolute, but 9 times out of 10, for surely H. Sometimes halogens are a center atom, but more or less, H's and halogens are outer atoms. And I don't know if outer has 2 T's or not. I'm not feeling 100% confident on that one, but we're going to move on before anybody else notices. So, that being said, I'm going to put carbon in the middle. Now, how many outer atoms do I have then? 4. It is not this and this and this, and like it's all going to the middle. So right away, if you think about your center atom, that's setting up really nicely, isn't it? I have 4 dots that are sitting there. So some of you, if you don't need to do the circle like this, probably not needed. I probably can go, you know what, that's probably just going to be a bond. So my goal for you already is to push yourself on even drawing the dots. Like if I did this one right now, I would have gone, oh, here we go. Why? Because in theory, what this was that, right? And then I circle those, and then those 2 become the bond, and then it's drawn right there. But I'm going to do it anyway like that, because I think that's important to see. What's the other goal I said? Is that I want to try to make that lone electron pointing towards the middle. How do you know where, if the hydrogen's on the left or the right or top or bottom? I have no idea. I just picked one. That's all stuff that you can worry about later. So, is this correct? How do I do it? First, do I have the right number of valence electrons? Does this have 26? 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26. Let me give you a little tip. Notice I call these spokes. It's probably a really poor choice of words, but this spoke has 8, right? So if I go 8, another 8, another 8, like I can count it faster. That's 24, and then 2 more is 26. So if you see some kind of a repetitiveness, do they all have octets? Well, okay, the Cl, 2, 4, 6, 8, 2, 4, 6, 8, 2, 4, 6, 8. The carbon has 2, 4, 6, 8 touching it. And then the hydrogen, some of you will do this and blow up the earth. Like, it must all have dots. It's like we teach you Avogadro's number and everyone's like, I don't know what Avogadro's number is. And then the next thing you know, you're using it on every single calculation. I'm like, but I thought you don't know what it is. I don't, but I'm using it because I thought I had to. Just because we have dots doesn't mean you have to use them. There are 3 exceptions. Have a ball with, I don't know, still working on that one. But they don't. That's an exception. It can't. So you're going to have to be okay with making an H with a single line. And that one's done. Okay, one more quick one, and then we're going to do some more problems. Last one. So, please, figure these out for me, quickly. Last one. Yes, it is aluminum. Figure it out. Or as the Brits would say, aluminium.
Aluminium.
We're not done. We're going to go right up to the bell. Probably. This is an important day. I hope you said 3. And then you said 7 times 3. Okay, here we go. Stay with me. What's my center atom? Aluminum. Okay, aluminum has 3 dots. Is that going to work out nicely?
Yeah.
Can I just make bond lines to my BRs?
Yes.
Because how many times does BR bond?
3.
How many times? Oh, that's not what I meant. How many times does 1 BR bond? Once. We'll get there. We'll get there. So once I see that once, why not kind of complete it? Those of you with really jelly pens or very inky pens, this is your time to shine because you're going to touch and it's just going to be in a perfect circle every time. All right, so if I count, what stands out? What's not okay right now? Al does not have an octet, right?
Oh, that's an exception.
It's not right. Right, do I have 24? 2, 4, 6, 8, 10, 12, 14. Shh. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. Al cannot have 8. It's as good as it's going to be. So Al and B, look, please see it on the periodic table so it makes sense. B and Al have only 3. They can't physically get to 8. It's just as good as it's going to be. Those are, besides H, that's it. Out of 118 elements, for us to say these 3 aren't going to follow the octet rule, I'll take that. That's not a bad deal. We're not going to say like in 2 more days, like, oh, and by the way, here's another list of things. It's not going to be like that. Okay, so what I'd like you to do is let's look at our worksheet. Okay? Keep out your little half sheet and let's look at your worksheet. Oh, supposed to be that. Just the front is due tomorrow, the back is due the next day. Okay, we need to get through this though, so I need you guys to have a great attention here. Underneath here, what I would do right now, do this with me. We're going to add these up. O has 6. This says 7 times 2. I'm getting that right from the table. And be engaged. It helps. Just writing stuff down and not trying to think about where I'm getting them from doesn't help. So I'm looking and it's group 16, that's a 6. Group 17, that's a 7. So my total valence electrons would be the 20. I like at least writing an E so it doesn't have like no meaning. So I'm writing that under total valence electrons. Okay, now, bless you. Now there's this big line. Oh my gosh, it's like a yawn. Okay, we're all nice. Let's no more bless yous. We all care for each other. Here we go. I have to get through this. What's my center atom? O. So the F's are on the outsides, right? Okay. If I do the F's, I'm going to do the F's first. I want to talk about this. Look at O once. It bonds 2 times. What would be a smart way of setting up my O right now? Putting the single ones towards the outer ones, right? Now, if you're like, well, what if I drew that first? Then you know what would have been a smart move? Doing that, right? Because then I could have bonded it like that. But I didn't. So I bonded it like that. Did I do it right? I have to have 20. Yes, I did. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. Do I have octets? 2, 4, 6, 8, 2, 4, 6, 8, 2, 4, 6, 8. It's got to be right. The last part you don't know how to do yet. We got to do it. You have to get through this. If you look up on your little half sheet, there's all these electronegativity values. I'm going to write them really tiny. Correct me if I'm wrong. I believe it's 3.5 and 4.0. The difference is 0.5. If you look at your note sheet right here, or actually the little half sheet, there's a table. Where is 0.5? Is it polar, non-polar, or ionic? Polar. So I'm going to write the word polar. And then the last concept. We're going to do one more problem then at the end. You have a big OF here. We need to draw this thing called a dipole. Don't draw that yet. It shows where the electrons are going. All you do is you point it towards the bigger number. So this is like the positive end. Because it looks like a positive. So the F is bigger. So I draw it towards the F. We still have a minute. Last one. And if we're done, you'll want to quickly just stay and see the beginning. Look at number 4. I'm just going to start you off. Sometimes there can be more than one center atom. So I'm going to jump right to the middle. If I see carbons, what if I have 2? If I had that, what would make sense symmetrically in space? What would be surrounding each C? 3 H's. So I want to think about that. And then you bond them. Before you go, the last thing, if it's non-polar, you cannot draw an arrow on the last column. If it is non-polar, there are no poles, so you can't draw an arrow on the last column.
Oh, we got it.
Work on the front page only. Bring questions tomorrow in class, okay? Thank you, guys.